Welcome back to the Niagara Learning Channel. So, the last video I showed you was a station that has been written, I think, by a trend guy, but I don't know. I mean, BQL expressions normally is a giveaway. So we've used this in A in B divided by in A, take away in C, times by in D, minus in E, plus in E as out. The simple answer to that is you could have just used, instead of where you've got your outside air max and min and your VT max and min, going to this minimum block and then going to the set point. So all this logic here could have been simply written in one block without using any of these expressions. Let me show you what I mean. I've redone the software and redone all the graphics. While we're still on here, let me just show you some of the graphics. I know they've got no values because I'm just looking at a copy of it on my PC, and then I'll show you what I did. So let's go down to, here we go, this Duns Barn. So let's go through the graphics first and then we'll carry it. Well, no, let's look at that VT business. So I want my logic and VT heating. So this here, this VT calc, basically you can put your minimum, your maximum, and your VT set point max and min, and it will automatically calculate for you the set point. So if I, for example, put the outside air temperature to really high, so if I emergency override that and put that to something like 25 degrees outside, you can see it's gone to 40 here. And if I put this back down to 0 degrees outside, we have got the 75 degrees. So that's, I think, using the reset block. Now where you find the reset block is if you go into your kit control and go into your maths, and you'll find the reset block there. There we go, that's your reset block down there. And then what I normally do is I do my pin slots and I do my in A and my inputs and my outputs, and then you can add in your values rather than going through what we've just seen. Anyway, just quickly go through the logic. So frost logic, it's just your normal temperature, your set point going into a T-stack with a differential of 2, which is 1 degree either side. And the boiler logic, very simple, pressurization unit. There's no fire alarm here. Any demands from hot water, heat miser, pool or VT heating. So long as the PU is okay, pressurization unit, we can then start. And we're running the pump there. We've got no on delay for the pump. We've got an off delay of 20 minutes. And this one, we have got an on delay of 2 minutes for the boiler. So basically the pump will start running first. 2 minutes later the boiler will start, and then we've got a 15-minute off delay for the boiler. So when there's no heating demand, it's 15 minutes off delay, and the pump is always going to, because we're adding here onto the boiler off delay, we're adding so that the pump will always stop 5 minutes after the boiler. So we can run it on basically to remove any heat that's in the system. So we don't want to shut the boiler off and the pump off both at the same time. We always want to start the pump before we start the boiler, and we always want to run that pump on for 2, 3, 4, 5 minutes or more before we actually shut the pump off. We don't want to get any faults there. Domestic hot water, again standard set point temperature, T-stat, differential. We've got a loop for the actuator there. Nothing really special about that. Pool heating, similar type of thing, set point, temperature, T-stat. AC system, so we've got PIRs in the rooms, and they will stay on for 17 minutes. So that's our off delay, 17 minutes. In that particular games room it's 15 minutes. I've left this here in case the user wants to be able to turn off the AC, so it's not on, but at the moment we're using the Crestron to enable it. So we can enable the AC for the gym via the Crestron system, or we can enable it via the PIR system. But I've left that in there in case we ever need to disable it. So all we would do is, if someone turns off a Crestron AC system, if we link that one into the gym up here, then that would turn itself off and will not work on the PIR. Optimizer's not being used. All I'm doing there is taking that to there, but I'm not using it. The normal schedulers here. Now we've got a generator and they wanted a generator switch, so naturally the scheduler comes on a Monday, 10:35 to 10:36, so it's 1 minute. That's what they asked for, and then but they've got a switch that they can switch it on themselves, and that takes us to the generator enable there, start signal. All the I/O, I put all the I/O into my own folder, so I've got the mix 38 points and mix 18 points and the Crestron points there. I'll just move them properly there. I'm using date and time. I'll show you that in a minute. So let's start at the home page. You can see there's a lot more PX files. All these are time clock PX files, so they can edit it. Now I've took in account that the screen size is very small and it's a remote screen on the panel. So what size have we got here? We've got 800 by 600 total size, so it's quite small, but it's just a fascia, a touch screen on the front of the panel. I just put some temperatures there on the front page and showing the set points. You can't adjust the set points, you've got to physically go into the page. Whoever's logged in, and then the date, the day, which you may have a problem trying to do that. I'll show you how I've done that. The date, that's easy to get. The time's easy to get, but that may be a bit harder for you to get. And well, we've got morning, afternoon and evening, but that's easy enough logic to sort out for that. I've put a PX at the bottom for all the digital inputs that I really want them to see on every single page, as well as the analog outputs there. On the top, again, it's just been put on there, Control key Z, Control key Z with all the temperatures there, and then the left is also a navigation bar as well. Let's show you the top first. So we want header, don't save that, so that's the header. Just a normal log off button, outside air temperature, and as you can see and then that is for our alarms. So if I click on there, that takes us to our alarms page. And click either Duns or Home. Duns will do it there. That'll take us back to our home page. VT heating. So bear in mind it's a touch screen, so we've had to condense quite a bit, but I've used sliders as well. They can press on that to adjust it, and they can put in their temperature like 25. And the slide, but we can also move the slider as well. And sometimes on a touch screen it's better just to move a slider than mess around with pressing that and putting in a setting on a number on the keyboard. So we've got sliders on here for everything. Just information. Every point you can click on and it will bring, it's bringing it up here at the moment. It'll bring a pop-up. Close that down. So every point, including the valves, temperatures, pressures, all these here. Again, it's just brought the pop-up on the other screen. This is not a live system, this is a controller that's on my my desk. Boiler, so that's our boiler graphic. Again, you've got your sliders. Domestic hot water, slider for the set point. Pool heating. So we have a maximum valve that they wanted, so that it won't go to 100%, go to 70, but you can adjust the maximum set point there, as well as you can adjust the minimum set point on the loop. AC system, just the games room and the gym. That's the generator. They're the meters, a 3-phase meter and a single-phase meter. Again, you can click on these and they will give you the history. And then they've got solar. So they can use the solar for domestic hot water, or they can use the solar for the pool, or they can just use the gas boilers. And then of course you've got the different schedulers that they can select. That's basically it for the graphics. So there's not a lot going on really, but bear in mind it is a touch screen on a panel, so it's better to go with the sliders if you can, but they can click any one of these. Right, let's go into some logic. Let's have a look at some quick logic first. So that was our VT heating. Let me put that back to normal. Outside air. That's our frost. That's our boilers. There are heating demands, VT, pool, heat miser, or hot water. Any one of them demands will actually put the gas boiler on. Domestic hot water through the time clock there. Time clock for the domestic hot water, and we're not in high temp, and we're not using the solar. If it was using the solar for the hot water, we would basically bypass this bit here, the time clocks, or that, and we will put it straight into the loop enabled there. Sorry, we won't be bypassing the control logic there for the loop, that's still the same. But what we will be bypassing is going through the boiler heating demands, because it's using solar instead of the heating. You won't really get, I shouldn't imagine you would get a high temperature on solar, but I could be proven wrong there. Cold water booster from Crestron. I don't know why that was there, but it was a point from Crestron. I don't know why Crestron's system will be monitoring the cold water booster unless it's to turn it on and off. But why would you? I don't know. So I've left that just in there. Pool heating. Again, we've got our loop there. This is our minimum and maximum. So 70% there is going into that maximum and 0 for the minimum. So it won't go above 70%. Naturally, we can set that to 100 if you want to. So actions set to 100. And then now that will go up to 100%. AC system is just, all this is doing here is changing the minutes into milliseconds, because we use milliseconds for our delays. The optimizer we're not using, I've said that. The schedulers we've already looked at, and the IO we've looked at. So the date and time, what I did here is I've got a calculate day folder and calculate day period, where I've put the hours in and the minutes. So let's have a quick look at that in case you ever want to do that. So we've got our hours, and we multiply our hours by 60 to give us minutes, and then we add our minutes to it, so that's giving us our total time in minutes there. And then in morning time, if it's less than or equal to 719, then we will flick that switch there, which will give us a 1, which 1 will be morning. I'll show you this here. One is morning, 2 is afternoon, 3 is evening. So let's take that back. Save no. And then we'll do the evening one. So if it gets over 1080 minutes, we're then in the evening. I think that's 6 o'clock. So that's with the evening. So if I change this at the moment now, emergency override, put 1800 hours. Yeah, we're in the evening now, because we're over 1080 minutes. So we're now in the evening. And then what I did after that is I just took these two, put them into an XOR gate, put a knot on there, so I know if it's neither one of these, it's going to be afternoon. Let's just put that back to normal. And that's afternoon time. So it's not this one, it's not evening, it's not morning, it's afternoon. If any of these, if morning comes up or evening comes up, naturally that will be false. So we just get 1, 2 or 3. So that was simple enough. That's basically for your greeting. You could say good morning and whoever the name is, just to show you that PX file again. And all we're doing there is using that date, time, the period in that in my logic for date and time period. That's normal. That's just using the station slot and the user brackets, open brackets, close brackets, %. So that's whoever's logged on. So afternoon, I'm logged on, Paul, and then 13th of the 10th, the date, which is normal. You can get that by out value. Well, I'm using my date and time date, and the same for the time. Now, just to show you that, if I go back into my date and time folder, you can see the time there, and you can see the date there. I just separate them, that's all. And it's easy to do, but that's the full system date, as you can see. And then I separate them to the parts that I need out of the system date and the time. Now for the day, the calculate day, that was a little bit more complicated. So we put the day in there, we put the month in there, and they put the year in there. And then inside this folder is all the calculations. So there's our day, there's our month, there's our year. So we need to find the month code. So the calculation is a year code plus month code plus century code plus date number minus if it's a leap year code and then mod 7. But it's not that complicated, but you've got your month there, so we're in month 10, and these are the outputs that I want. So January I want a 0, February I want a 3, March I want a 3, April I want a 6, 1. This is all to do with the calculation. So all I've done here is, depending on what month it is, I will output. So we're outputting a 0 at the moment because we're in October, so we're outputting the 0. So that's not too hard. If you want to copy that, just freeze this screen and then you can add this, all these. I think everything's shown. Yes, everything is shown, apart from I didn't show you the bit there. Let me just pin slots. Everyone the same as the in false. The in false is null on all of these blocks, and then if it's true you will get a value coming from that, as you get with this month here. True, we want a value of 0 and we put the 0 through to that. So that was our month code. Our year code, they're all rubbish, don't need them anymore. They were me just messing with things. Our year code, so year plus, and then in brackets year divide by 4 close brackets, and then mod 7 at the end of there. So all we've got is we've got the year coming in there, and we're taking out the 20, so we just left with the 25. We're putting the 25 into there, and we're dividing it by 4 to give us 6.2, and we're doing the 25 plus the 6.2, the total there, we're mod 7 it, and it gives us a value of 3 for our year out. So that's our value 3 here. So the day is just a normal day, so we're adding the day, the month, the year. Now down to the George Gregorian calendar, or whatever you want to call it. Bit more complicated. So the 1700s was a 4. I mean, yes, you can go back with this, but really you only be going forward. The 1800s is a 2, the 1900s is a 0, the 20,006, 21,004, 22,002, 23,000, 0. And all we're doing here is I've got these in here, the 18, 19, 20,000, 21,000, 22, 23. Again, I'm just putting through what it wants on the number wise. So we're getting a number 6 from there, and as you can see 20,000 is 6. I was doing some more playing around here, but I would ignore this if it's really not necessary. And then I was doing the month, calculating the month, is it January or February, the month, and that actually I think wants to go, yeah, month there, and that's wrong. So let's just take that out and put the actual month in there. And it's not January or February, so we're not a leap year. Yeah, so it's got to be January or February, and it's got to be a leap year to go through and do the final calculations. And it's not them. Once we've done that, so it's not a leap year, we do our date calculation there, and then we mod 7, so today is a Monday. Now you can play around with this. You can put your date of birth in there if you wanted to. If I put mine in there, set that to 24, set that to 5. Hopefully they override it first. Emergency override 5. Emergency override 24. Actions emergency override 1964. So apparently I was born on a Sunday. Allegedly. But all this is doing for me is just basically telling them what day it is. Now I'm sure they know what day it is, but I'm just displaying that. Emergency auto, and today's day is a Monday, which is correct. Okay, so that was that bit of logic. So 1992 is a leap year. Actions emergency override 1992, and we've got our 1 there because it's a leap year, but it's not January or February, so that's why we're getting a 0 there. So if I put the month to January, I should have got a 1 from there, so that's true. Leap year true, true, true. And that's the reason it's not working, because I haven't put in my 1 there. And now it will work. So that's your leap year. So it's a leap year. 2000 was a leap year. 2000. So we've still got a 1 there. But 1900 wasn't a leap year. Actions, emergency override, 1900. And I've got a 0 there. Still in January, but I've got a 0 there. It's not a leap year because you can divide it by 100. So 1992 is a leap year because you can divide it by 4, or 2000 leap year because you can divide it by 400. Anyway, that's working out whether it's a leap year or not a leap year. Put that back to normal. And put that back to normal. And if you do this logic, write this logic, you can play with it yourself. But it's nice to keep. But you may use it, you may not. All it's doing is giving you the day. Not the date, the day of the particular Monday, Tuesday, Wednesday, Thursday, Friday, Saturday or Sunday. And that's it. I think that's enough. I've waffled on enough for this one. Alright, thank you for watching.